remember, you can do the thing no matter what you're doing, no matter what's going on. I believe you can get it done. Anyway, how are you all doing today? You know, how you doing? Today is Saturday. I know I am streaming extremely late. My wife had an infusion that she was supposed to get. However, we went to the infusion center and they're like, oh, you're not on the list. You're not scheduled and I can't find you scheduled anywhere. Pissed me off a lot. So that was supposed to be at 11 o'clock this morning. Didn't happen. So after coming back and going to Arby's, eating some food, coming back over here, you know, I finally eventually got better enough to stream. So I am streaming it up. It's still be an hour. Yes, unfortunately, it is a bit late. I am really sorry about that. Tomorrow should be on time with the 68K programming. I didn't send my tweet out, did I? Did I? Tweet. There we go. So, yeah. Yeah, that's kind of what's going on. Anyway, what's been going on in my life as that programming guy? Not much. I got to see someone wear my shirt. That was really cool. Shirts are in production. I'm developing the Twitch extension. I'm right now trying to do it so I can collect, money from people. So I'm probably going to use Stripe because Stripe's documentation is so much more easier than Square's. So look for that in the next, 1 to 2 weeks. I do go back to work on the 13th, so in 10 more days. I'm hoping to get it done before then. And what else is going on? I don't know. Started StarCraft 2, so that's fun. I don't know. Anyway, so let's talk about where we finished last episode, shall we? So last episode we went through this gist, which was just basically using global variables to do the maze thing. We had finished basically going over this behemoth. I finally understood IX was a function, really got the composition under control, figured this out. So like, all right, now that we got this, now it's the next gist. So the next gist that was supplied is the maze generator, like we read last time, but we're explicitly passing the configuration object between functions. So let's start going with that. I'm feeling not good right now. I don't know if it's because I've had too much coffee or I've had too much water. I can't tell. I hate it when that happens, though. When you drink too much coffee and you get tired, I'm like, am I tired because I'm actually tired? Or am I tired because I've drank too much coffee? It's never fun. Dregs. Coffee dregs. Problem with French press. So we're going to go through this. It also might be just because I'm tired today. I don't know. Today hasn't been a good day today. It's been a lot of annoyance and angry. Anyway, so explicitly passing configurations between functions. You can see that every function that is used in association with the function that uses the configuration object has to take a configuration even if it doesn't use it. Enter width, get the width. W, read. Oh, right, this means fmap, because I remember that from last time. So $sign is fmap. Put string ln, enter width, get line. Oh, what's right? Probably does get line. I think it's this, then this. And I think so. So you're mapping this to read, put into width, and you're mapping get line over read for H, and then make configuration width and height, let configuration into that, print configuration, then fill maze, take the configuration, fill maze configuration, take that. Okay, interesting. Okay, so read Haskell. The convert string to value. The text.read library is a canonical library to import the read class facilities for GHC only. It offers an extended and much improved read class, which constitutes a proposed alternative to the Haskell 2010 read. In particular, writing parsers is easier and the parsers is much more efficient. I wonder if Moonman's going to join me today. Parsing of strings producing values. Derived instances of read make the following assumption, which derived instances just show obey. Okay, that's fine. How do I use it to read A where... you're not helping me at all. Read. This is get line. This is the bind operator. So it's get line, I think binding it to M, right? Oh, what's the correct vocabulary? To understand the difference, you have to understand. No, I don't have to understand monads. It's the bind operation. Defines X to be equivalent to action, but does not run anything. Okay. You know, fuck you. So you're binding Y to X. Okay. That's not really helpful. Yes, I know I'm streaming. Thank you. Oh boy, so let's believe it is the bind operator, right? Runs the IO action, but gets the result and binds to text. Okay, so it binds the result to X. That's cool. So this does get line, binds the result to name. That makes sense. So do you have read on here? Read means any type of read class, and it takes a string and returns any type. So read. Oh no, this is the infix notation. So otherwise it would put string, get line, and then read. What's the double arrow for? Takes a monad on A and a monad on B and returns a monad on B. From there you can just take a look at the source code. How do I look at the source code? Oh, this is okay. It's a sequence of actions, and it does not worry about what you get. So basically, this sequence is actions. So basically, it's put string enter with, and then just this get line. And get line doesn't care about what this. Okay, this is sequencing actions, and then we're f mapping read onto this and assigning it to, and binding it to W. So if I go to CMD stack GHCI, can I use it here? Or are you gonna do a lot of things that I really don't want you to do? Oh, and prelude. All right, cool. Read. Okay. So you take a string and return an A. Cool. That's so helpful. For f maps, so if I'm correct, if I basically go like, if I'm this, I do $2, it's equal to f map, I don't know. Okay, so $2 is equal to f map $1.3 times 2. So I think so. I think so. Oh, hey, people. Google is your friend. Read as a type class allows you to simple deserialization from strings. It's the duel of show. Hello, Segfault. How are you doing today? Thank you so much for joining me. Now that I have someone to talk with, I'll actually have to remember more to actually read my laptop screen, huh? This coffee is gonna go there. Oh boy. Yeah, Google is my friend. I haven't spent much time trying to learn it. Yes, I know it is fmap. I do understand that. So I'm trying to figure out, is it, if I would to write this with fmap, is it fmap this and then this? And I think so. I'm not really sure. So I was trying to just figure out the order of, if I take the infix notation away and I write fmap, how it's going to work. Unless it's just basically, if you have a 1, that 2, is that equal to fmap 1, 2? I think so. Anyway, so that, and then we read, and read takes a string and turns it into an A. Oh god, which means that, oh, I'm on Windows 7, which means that's not gonna work. Type yes, returns an IO of a string. Okay, cool. I thought so. Your f mapping in IO, yes. Dear serialization, what are the user password via get line? I see. Yeah, so this returns an IO of a string, and your read will then take the IO of a string, and it'll change whatever gets to an IO of a string, which makes sense because W is using bind, so it has to be bind to an IO. Get height, then configuration uses make configuration. And for config, we have width, height, and cell count. Make config takes the width and the height and returns a configuration. This makes total sense. CP, make config 5.5. I'm assuming this is a CP stands for common configuration. I don't know. Anyway, so we did this. This makes total sense. Configuration. This takes fill maze with the configuration, takes the output from fill maze and puts it into render maze using that. Interesting. Okay. All right. I can do this. I'm equipped to do this. By the way, everyone who's watching, I just want to let you know, I want you to feel bad for me. It is slowly getting hotter and hotter and hotter in this room. It's actually quite interesting. It's like an endurance test. Fill maze L conf. And Segfault, how are you doing today? Because I've actually never had a chat with a lot of... The only time I've actually had a chat with people while doing this was when I've been helping Asmodan. So fill maze L takes configuration. What does fill maze L do? This is all the stuff about mazes. Fresh cell, move to index, from index, valid moves. Yes, I know all that. Maze function, add neighbor. Hey, it's this again. And fill maze L Takes the configuration, returns an IO of a cell list. So fill maze L. Yeah, it's because it's summer here. And I don't want to open the window because, you know, I don't want any noise. But two, even if I could open the window, right now they're painting the apartment building. And so every window besides this one actually is covered with plastic. But they're painting, so it means you're going to hear paint sounds, you're going to hear people talking. And I kind of want to make... And also my computer's on, and there's no fan in here. So it's like my computer is my demise right now, but I have to have it on. And it takes config and turns an IO of a cell list. So that means that the function that we were looking at, which is... So if we look at fill maze L... God, I really get two monitors when I do this. PUTSTRLN dot render maze config. Basically, oh, I get it. So yeah, fill maze config, which returns an IO of a cell list. That IO of a cell list is then put into render maze. Okay. Point frame notation. I mean, when you were doing the Asmodan Python stream the other day, yes, I was doing that last week. And that was fun. I enjoyed doing that. So fill maze L takes an IO. So I'm starting to get this. And fill maze L is the same thing, where it takes a configuration object and then does that. Do let L replicate. Basically make a bunch of fresh cells. Traverse. Oh, I forgot what traverse did. Borders. Oh, this caused borders. Oh, I forgot what traverse did. That is true. Hoogle is a thing. Let me try to use it. If I am correct. I can type worth shit. Come on, me. I should know how to type. Nope. Hugo.haskell.com. Okay. Traverse. Oh, I can actually click on it. Oh, that's cool. I didn't know that. Map each element of a structure to an action. Evaluate those actions from left to right and collect the results. I see. I remember this. Traverse is just an F map instead of an arbitrary applicative. Huh. What's an applicative? I know I read it. I read the Haskell book. But it didn't really help. Like, the Haskell book helped in, like, for me to understand some Haskell syntax and everything. But besides that, not much. Like, I read about monads, applicatives, functors, testing. It helped a little bit. Traverse takes an applicative, takes a function that takes A to B, it takes the traversal on A and returns an applicative on a traversal of B. So this is the function, and this is this. 0 to cell count, configuration -1. What does that mean? Borders is a function here. Borders takes the configuration, takes the index, and returns an IO direction. Where do you use L? Oh yeah, add neighbors. Pure fold L film. Basically just fill in the maze. I know I've looked at this before. Takes the configuration, index, and returns an IO of direction. I don't know where it gets the index though. Applicative is a functor with pure and that enabling parallel sequencing. Oh, interesting. Okay, thank you. Basically, this fills the maze. Replicative traverse builds the maze. Basically, what this does is it makes fresh cells. It gets all the directions, and then it mashes the two together. That's what happens. So fill maze L basically gets the filled maze with a bidirectionalness. Once that's done, the result is passed into putString ln with the print with render maze conf, and because of the dot, render maze runs first and then putString l. That was fast. Didn't have to go through much. All right, so that's kind of what it is. So basically, it's like he makes a configuration object and he passes the configuration object around, which even in object-oriented programming, it's the same thing. It's like, all right, you know, should I pass these three variables around, or should I make an empty object that just has these variables, or should I make a tuple or something like that? I don't know. It's really interesting, but yeah, like 3, It's getting there. I don't know. 3 or 4 is when you really need to be like, should I pass a configuration object around or not? Although that's really cool. Although this makes sense that the configuration has to be passed around no matter, even if it uses it or not, because you need to keep this information in place. And then that's understood. The maze generator with the monad version. Here we see that we don't have to manually pass configuration to each function. However, the cost of this is the functions have to be written in monadic form, and then to access the result, you use run reader t to run the function along with the configuration. We are using a reader t transform because we are creating a monad transform with a config and IO. I know what I could do. I bet I could have OBS play me a jingle of some kind every time I get a message, so I don't have to keep looking over my screen. That's an interesting idea. We are using reader. All right, language. Yes, phone. We are use a language flexible context. Need to use MTL style type annotation. Well, that's new. Multi-way if allows if guard hybrids. Constraint kinds allow constraining synonyms. What the hell? That's interesting. Without flexible context, all type class constraints on function definitions must have type variables. For example, num a, AA is that. Where a is a type variable, with flexible contexts enabled, you can have any type inside a type class. This example is pretty contrived, but is the simplest I can think of. Flexible context is usually only used with multi-param type classes. But I can do this without enabling it? Okay, that's interesting. Next, I guess, would be multi-way if. La 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 diddly 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 doo bada 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 diddly doo. The multi-way if. Whoa. No, don't you fucking restart, computer. I will kick your ass if you do. The multi-way if extension allows you to use the full power of Haskell's guard syntax in an if expression. For example, this code, I guess? I mean, why not just, okay, fine. Constraint kinds. Constraints in Haskell mean one of the following. Class constraints, okay, kinds, yes. I remember that. Classes and contexts were not first classes in Haskell, but the introduction of kinds has changes and allows them to use as parameter of types. Type synonyms can be used on constraints. Huh, interesting. Okay. Bop, bop, bop. The module describes a structure intermediate between a functor and a monad, technically a strong lax monad functor. Compared with monads, this interference lacks the full power of the binding operation, but it has more instances. It is sufficient for many uses. Instances can be formed. The interface was introduced for part. Okay, that's fine. An applicative is a functor. A functor is what? Functors uniform actions over parameterized type, generalizing the map function on lists. The functor class is used for types that can be mapped over. Okay, instances of functor should satisfy the following laws. Fmap on line D is equal to D. If you compose F onto G, we get Fmap of F composed. So we basically Fmap of G and then Fmap F on that. Okay. A functor with implicative providing operations to embed pure expressions and sequence computations combine their results. Alright. Interesting. Okay. A minimally complete definition must include implementations of pure and of that or lift A2. If it defines both, then must behave the same as the default implementations. Further, any definition must satisfy the following: identity, composition, homos. Haskell descriptions are always not fun. Like, there's so much, you know? I don't know. Because it's like, alright, we're going to describe this in proper syntax. And now I'm tired again. It might be the coffee or it might be the water. I don't know. Anyway. Let's keep going. Test 1 IO. Get the width, get the height, put conf for each. Let conf equals make conf to print it. Put string li. I didn't know you could do it that way. Show maze from configuration. Here's a list of reserved keywords. The block that you're asking about is merely a function, so we can ask Google. It tells us that is simply that with its arguments reversed. That makes sense. Show maze from configuration, and we pass it configuration. Takes a configuration and returns an IO of a string. Show maze from configuration equals run reader T, and takes the fill maze and takes the output does render maze and run reader T. And you mentioned that. However, the cost of this is functions have to be written in nomadic form. And then to access the result, you use run reader T and run the function along with the configuration. So I guess fill maze L is where we're going to first look at, huh? Takes a config RM and a monad IO M. And takes a cell list, which is a monad IO. I mean, this is fun. Fill L do ask. Okay. Random RIO, chunk of, fora, filter M, fold M, reader. Huh. Okay. Oh my god. Maybe I'm overhydrated. Maybe that's what's going on. Anyway. I see. So you pass it in, but you don't say you're using it, but you still pass it in? Huh. I see. You take it. Okay, interesting. So show me some configuration with configuration. And this you say you have it, but then it just kind of goes away. Okay. Do you not remember the reader monad? No, I have no idea what the reader monad is in the first place. Fill maze L. Yes. Ask. Fuck you. It's worth rereading. I've never read it in the first place. Why do I need to read it? I'm not saying you're wrong. Monad reader. Thanks, you did not help at all. Computation wants to read values from a shared environment. Oh. Oh. Cool. That's awesome. And so ask will probably then take that. I get it. Uh-huh. Sorry, Segfault. What I was... A reader is fairly fundamental, worth understanding. Yes. No, what I wanted to avoid was being like, read the reader monad. All right, here's 5 pages that you have to read in order to understand the monad. I just read the first line, which is like, it allows you to get these things. Computations which read values from a shared environment. I'm like, oh, cool. This is the only line I need. And so that way, when I go, oh, I need to get values from a shared environment, or I need to store the variables somewhere and get them back, I'm like, okay, cool, reader monad. Let's read more on that. But just knowing that this is to read values from a shared environment is totally just exactly what I need. Retrieves the monad environment. Interesting. So ask. Okay. Interesting. That's valid index. That's not what I need. Ask configuration. Okay. Config rm and a monad io. So many different type of classes. Filmaze L. What's a config r and a monad io and a monad io of a cell list? Oh, and returns it. Ask for the configuration. So that's just the whole entire shared environment. So replicate cell count configurations fresh cell. Oh, a map M. Ooh, fancy. Oh, I see. It's just using the monad versions. Okay. Config R on monad IO. I see. So this is print show maze from configuration. Config IO. Run reader T. Fill maze and render maze. So config is just a config driving show. Where does it get set? Where does it get put into the shared environment is my question. Borders, fill maze, get choices. To index, yes, phone. What do you want to tell me this time? Somebody that I know is streaming. Oh, render maze. Config rm. Render maze is not what I need yet, because that's next. Run reader T. Run reader T takes an R and an M and an takes a run reader T, which is RMA, and returns an R and returns a monad on A. I see. Interesting. So if I go here then, since you said run reader T, if I go to la 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 selection for reader T identity. Parameterize reader monad. Computations of functions shared environment. The return function ignores environment. Run reader. A reader to run an initial environment. Okay. Why is an initial environment R? Why aren't these parameters like 1 letter long? It's so annoying. The reader monad I see transformer. Oh, okay. Run reader T takes a reader T, R, M, and A, and an R, and returns M, A. R is the reader, A is what's returned. Runs read and extracts the final value from it. Oh, interesting. Okay. Huh. Interesting. So, run reader T on this. Fill maze and render maze. How is that? Well, my question is now this then. Like, run reader T takes the reader T, RMA, and an R returns MA. So this is the function. So where is configuration in all of this? Unless it's like point free, so like it's going to just put at the end of this? This is confusing. That does not help at all. And this is the same with read mode. It provides access to variable bindings. Bindings are a map of integer. Show maze from configuration is point free. Okay, that's what I thought. That's what I thought. Let me read double nine again. Fold R plus 0. X's, yeah. Point free fusion. Notice it takes in configuration. That's your environment. Yeah, that's what I thought of. Where it's like, this is the configuration. So my guess is that run reader T will understand to take basically like would put the configuration like right here, and it would and basically. Okay. So we have run reader T. Run reader T takes a reader T of R, M, and A, and an R and returns M and A. So this R right here is probably the configuration right there. That's probably what it is. And the R is the initial environment. So takes run reader R, M, A, takes R. Oh, Shiny Zen is live. That's what it is. Remember that all functions are curried in Haskell. The call to run read is partially applied. Okay, hold on. M and A. I see it's partially applied. Yes. Oh, you know, yeah, I know. I totally get that. Yes, for example, to show you of my... And the M is the I/O. Oh, okay. M is I/O. So, yeah, like, for example, if I had... let me write this a bit bigger. You know, so if I had a function foo, right, and I just returned something I can't remember off the top of my head, but let's say I made a function and it basically did that, just 2. I could actually call foo with another number and it would apply that to that, like that. So yes, I do remember partial stuff. Yes. So run reader T takes all of that, and now I just change pages again. So RMA takes a something that I don't remember off the top of my head. Oh, la 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 la. RMA, R, M, and it returns an M and A. Monad on an IO of an A. So R is equal to initial environment, INITIAL, ENVIORMENT, M equals IO. A is what is returned, which is just anything. What we give it. So we are given, so basically run reader T takes 1, takes 2. So we have the RMA thing. We have RM, And then we have the fill maze equals render maze. And so fill maze happens first, then the output gets put into render maze, and so render maze returns a M string, an IO string. And so we got the IO there, which makes sense. So we do a R, and then basically the IO string. We turn the R of the IO string, and R is the initial environment. In general, monads don't compose. Monad transformers is a pattern for making them composable. Yes. Reader T is a transformer that takes an arbitrary monad M and adds a reader context to it. IO must always be at the bottom of the stack, if it's a stack at all. In this example, you have a reader T, config IO A for some A. Oh! Well, thank you. That makes a bit more sense. Yes, I remember watching a video about this guy, and he's like, here's my problems that I don't like. One of them he's actually saying is, yeah, monads aren't composable. You can kind of work around that by making transformers, but the only problem with that is you have to write a transformer for each composition. So if you have a, for example, reader T in IO, you have to add a transformer for that. If you have another kind of monad in IO, you have to write a transformer for that. And this is the thing where, like, what I think I don't like about this. What I think most people do when they're trying to teach Haskell is they're like, you have to understand all of this, you have to read all of this paperwork, you have to read all of this documentation to start writing code. And I don't believe in that. I believe you just have to go and figure it out as you go. And because we have the wonderful, miraculous miracle of the internet, I can go, here's this thing, what is it? What, go on Google, go on Stack Overflow, and go, let me try to figure it out. And that's what you do. If you want to learn Python, it's the same thing. You don't just start by reading a book about Python for 5 months and then start coding in it. You just go. You know, maybe you read documentation on how to set up and how to write a simple hello world program, but after that you just go. Now, of course, this only works kind of if you've been programming before, you know. For example, I've done, C#, C++, a bit of C, Java, Scala, and I can go into Haskell and go, let me start. However, with Haskell, I did read the Haskell book. But if you're moving from like C# to Python, or C++ to C# or Java to Ruby, they're all mostly the same. You just start going. That's it. Just start going, eventually make it better, and go, okay, now I need to do this in this language. How do I do this in this language? One second. If you look at MTL, you'll see instances of monad. What is MTL? You'll see instances of monad trans for all the built-in transformers, which gives you the ability to lift values through a stack of transformers. It requires tons of boilerplate, but fortunately, it's boilerplate. It has to be written once. Yeah, boilerplate usually needs to be written once. But yeah, that's just how it is. It's like, just go do it. I was in a software design class, and we were making a project. We decided I'll use Python, and we actually scheduled time to learn Python. And my teacher was like, no, just go do it. You're smart. And that's true. So if you're going between all these common programming languages, guys, not just segfault, because you're helping a lot. Monad Transformer Library, thank you. Not just segfault, but anybody who's watching this either on YouTube or Twitch or wherever the hell this is in the next 20 years, just go do it. Just remember, you can do the thing and just go do it. So, run. Oh, hey, I know. Let me do this. What? Okay. Oh, I see. I was doing the wrong thing then, huh? Aha! Kinds. Okay. So run reader T. We were saying partial applications to Haskell involve passing less than the full number of arguments to a function that takes multiple arguments. Simple. I see. So int add 1. Yeah, makes sense. Partially applying add. Takes 2 ints and returns an int. That makes sense. Add 1, so x and plus y. What? Hold on. In the example, add 1 is auto partially applying add. Oh, right, because you're saying add 1 and it just takes that. I get it, and then you can do add 1, whatever you want. I got it. That's a bit more confusing. Okay, so reader T, fill maze, render maze takes the first part, and the second part is the environment. Environment takes there. Okay, currying is the process of transforming a function that takes multiple arguments into a tuple as its argument. Into a function that takes just a single argument turns another function which accepts further arguments. One by one, that the original function we receive is the last, that tuple. Function A returns BC is the curried form of yes. You can convert these two types in either direction with prelude, curry, and uncurry. Function takes an A and returns a function that takes B to C. Yes, I remember, because currying is basically Haskell's or the lambda calculus's way of basically dealing with multiple things, because a function can only take one thing and return one thing, but you can curry it. And so what we're actually using in Haskell when we're having multiple inputs or parameters is basically it's currying in the background, so we don't have to worry about having multiple functions with different names just so we can do the curry, which is actually really cool. And I think that makes sense kind of now, how like we use the arrows. It really, I think that makes more syntactically understood, that we're taking this thing and it's going into this thing and it's going into this thing and it's going into this thing. Makes sense. So let's start getting rid of some of these. Run reader T. Run reader T takes an R. Oh, new type reader T. The reader monad transformer, which adds as a read-only environment to the given monad. Okay. The return function ignores the environment while that passes. Interesting. Okay. Run reader T. The reader T takes an R to an MA, monad on A. Run reader T takes R, M, and A, and an R and turns a monad on A. I see. The reader T monad transformer adds the read-only environment to the given monad. So in this case, our monad is IO, state, basically, and we're reading just a we're putting a read-only environment on that. Okay, so again, show maze configuration. I'm starting to sweat here. I guess I could take off my socks, huh? That's a good idea. Let's do that. 1 second. Oh, it returns an IO of a string. There we go. That's a bit better. Show maze from configuration. And takes out puts string ln. Takes the configuration. Let's get run reader T. Fill maze L and render maze. So fill maze L, so render maze, basically this returns an IO of a string. and then run reader T. So does that mean, but here's my question. You know, it's like, I'm assuming fill maze L, this runs first, and then is applied to run reader T. I'm thinking that's how it is. Because then we ask it, you know, we go here, fill maze L, we ask it to get the configuration. Replicate configuration, fresh cell, cell count configuration. What is cell count? This is an interesting thing. Where is cell count? Where is cell count? Ah, cell count. Oh, that's how he's doing it. Okay. Where are you? Fill maze. I see. So he's basically saying get the cell count out of conf. Oh, that's it. It's in the configuration record. Yes. Okay. Thank you. Fresh cell. Okay. Oh, okay. I totally get it now. I see. So this is the same. This has parentheses around it then. Oh. I get it now. Oh, config R, which is an M, and monad IO, which is an M. Config R. Okay. Where is config R, you bastard? I would assume it's in there. Some days I wish this was the Windows 10 CMD. That would be nice. You're still not in here. Nope. Okay. I see. So this is the reader monad, which allows you to read values from a shared environment. And the transformer is kind of composing the reader monad on top of the IO monad. Huh. Monads provide a powerful way to build computations with effects. Each of the standard monads is specialized to do exactly one thing. In real code, we often need to be able to use several effects at once. We call that the parse type we develop in... We have seen how monads can help with handling IO actions, maybe, lists, and states, with monads providing a common way to use such useful general-purpose tools. A natural thing we want to do is use capabilities of several monads at once. For instance, on top of any other monad. Yes. A function could use both IO and maybe exception handling, while a type like IO, of maybe of A would work just fine. It would force us to do pattern matching with an IO, do blocks to extract values, and that maybe monad was meant to spare us from. Enter monad transformers, special types that allow us to roll two mads into a single one that shares behavior both. This is the sentence I'm looking for. Right here. Cool. Not just IO. Okay, yeah. Well, I said IO because that's what I'm working with right now. Consider the real-life problem for IT staff or what getting users to create sung passphrases. One approach, force the user to enter minimum length with various irritating requirements. Here's a Haskell function to acquire passphrase from the user. Validation test. First and foremost, get passphrase is an IO action as it needs to get input from the user. We could use maybe as we intend to return nothing in case the password does not pass is invalid. Note, however, that we aren't actually using maybe as a monad here. The do block is the IO monad. We just happen to use return with the maybe inside it. Monad transformers not make it easy to write get passphrase, but also simplify all the code instances. So ask passphrase returns put string insert new passphrase, gets a maybe value, gets passphrase, binds it to maybe value, case maybe value just value or nothing. The code uses one line to generate maybe value followed by stuff further. With monad transformers, we would extract the passphrase in one go without any pattern matching, or equivalent bureaucracy like is just. The gains from a simple okay. To simplify get passphrase in the code that uses it, we will define a monad transformer that gives the IO monad some characteristics of the maybe monad. We will call it maybe T. T stands for transformers. That follows a convention where a monad transform is a T appended to the name. Maybe T is wrapped down M, maybe A, because we want to put something on top of a maybe, where M can be any monad. So new type maybe T MA returns a maybe T, then run maybe T. Okay, so run reader T literally puts the reader on top of the monad. Got it. Interesting. Okay, I'm learning so much. Segfault, thank you so much for your help. I get it. The data type definition specifies a maybe T type constructor parameterized over M, with the term constructor also called maybe T. And convenient accessor function run maybe T, which can access the underlying representation. The whole point of a monad transform is that they transform monads into monads. So if we need to make maybe T an instance of the monad class, instance monad M is a monad on maybe TM, where return maybe T dot return just, we wrap it, and then we put a maybe T on front of it. Okay, that is crazy as fuck. My God. Okay, that's interesting. So I get it now. Run reader T. Okay. This is quite spiffy. Okay. So run reader T from here is a transforma. So reader, the selector function to apply to the environment. So let me do this first. Reader examples. Haskell. The reader monad, more generally the monad reader interface, solves the problem with writing the same configuration to many functions. There we go. Type can we have a configuration. Load revisions. What the? Ugh. Your code looks horrible, my good sir. I don't want to read your help because I don't like your code. It doesn't look cool. In Haskell, occurs when pure mean functions can interact with the arguments passed to them. The effectivity means that we cannot have global variables. Consider the example as main I, yes. Basically, now you have pass environment, everything. The reader solution. The reader monad solves this problem. It effectively creates global read-only value of a specified type. All functions within the monad can read the type. Let's look at how the reader monad changes the shape of our code. Our functions no longer need the environment as an explicit parameter. Load environment, pass it into environment, run reader on the environment and function 1, and puts it a string and prints it. Environment is environment, load environment returns environment, function 1 takes the reader, reader, which is the environment and the string, do, function 2, I get it. The ask function unwraps the environment. Oh! Oh my god, I totally get it now. Okay, I get it. Numidamosa is solving a problem here. From what I've seen here, it looks like if you want to look at the environment and get a string, you have to write this function. If you want an environment to return an int, you have to do this function. I think basically he's putting it on top of an IO, so everything's just an IO. IO of a string. Right, because these aren't wrapped up in monads. Okay, so he's using the transformer to basically put everything into the shared environment variable. Shared environment, but is an IO string. I think so. Anyway, that is the end of the stream for today. It has been an hour. That is the end of the episode. Lurkers who are lurking, thanks for lurking. Watchers who are watching, thanks for watching. Bots who are botting, thanks for botting. In this episode, what we got done was we saw his second example, which involved passing configuration to every function. Was totally able to understand that. Made sense. I now remember the answer to my original question, which was because it's record syntax, that's how you access things in the record syntax. We are now going over the example now, which is him basically using the reader monad to share local data, basically environment variables, you could say. So we're going through that. We've read up on transformers, the reader monad, currying, partial applications of functions. We've done a lot. So that's great. So yeah, next episode, we're kind of going to continue from here. Make sure we understand transformers, make sure the problem of what we use readers for, and start to understand why he transformed a reader on top of the IO monad in this case. Anyway, everyone, thank you so very much for watching. This episode will be up on YouTube on my programming channel. You can look below to see how to get there on YouTube because I don't have a YouTube specific link at the moment because I'm not popular enough. Follow me. That'd be great. If you're watching this on YouTube, go ahead, subscribe to me and click that like button to let me know that you like what you're seeing, or click the dislike button to let me know that you hate it. Both work. But everyone, this is going great, and I'll be streaming tomorrow for the 68K programming at 11 o'clock in the morning Pacific Standard Time. But I love you all, and remember, you can do the thing.